Hello, everyone. Welcome to this session. We're going to learn how to query Azure Log Analytics with Kusto. My name is Paulo Ian. I'm a solutions architect for Micron Technology. So this session is recorded, but I will be online answering questions. So feel free to use the chat to ask any questions. So the agenda for today is this. We're going to start learning how to collect the metrics and the logs from different resources like the SQL VM and then the SQL database. And then once the data is collected, we are going to use the Kusto language to find anomalies and patterns. And you will see that it's pretty easy because Kusto has machine learning built-in functions, and you need to be a data scientist to figure out how to use it. And then we'll see how can we apply those concepts in the way we visualize the data with dashboards and create alerts when anomalies occur. And also all the scripts that I use are going to be available in the conference materials. So we have this architecture in our demo. So these are all the Azure resources that I already created. For example, we have VMs, we have a database, we have the log analytic agent, log analytics workspace, dashboards, and alerts. So we're going to start with the VM. So we're going to demo how to collect the data, the metrics, and the logs from a SQL VM. So we need the log analytics agent installed, and the VM can be on-premise or in Azure. So both ways will work. So we will go to the portal. Let's see, the portal looks like this. And as I said before, the VM is already created, is this virtual machine. You click on that, and we will see, if you want to connect, just click connect and RDP, but I already have the remote desktop connection. So we can see the VM already. So this is the VM. And as I said before, I already installed the agent. And the way you can see that I already installed the agent is if you go to control panel, the name of the agent is Microsoft Monitoring Agent. So you click on it, you will see that this agent can be used for Operations Manager or for Azure Log Analytics. In our case is this one. And you can edit the information if needed, and it will ask you for the workspace ID and the workspace key. So those come from the log analytics I already created also. So you go to home. So the log analytics workspace that we're going to use in the demo is called pslog. And you will find the workspace ID and the primary key on the agents management tab. So you just provide those values and go through the wizard, click next, and the agent will be installed. So once the agent is installed on this VM, we need to configure to see which metrics and which logs do we want to collect. So if we go back to our log analytics workspace, so now we go to the agents configuration. So here I already configured this Windows event log, the application event log, and it will collect errors, warnings, and information. But you can add other ones. So you click the plus sign here. You can choose other event logs. For our demo, we're just going to do the application one. Also, you can choose which Windows performance counters do you want to collect. I already chose some, the typical operating system ones, like a logical disk, memory, processor, and also the SQL Server performance counters are available. So all of them here, you can see I picked 3, the resource pool and the batch request and the SQL compilations just for our demo. And there are other things that you can collect for Linux, but we're not using Linux, and do the syslog and the islog. So our demo is just on Windows. So once I configure this, it will start collecting all the logs and metrics. And for example, if we go to the VM here on the remote desktop, if I go to Management Studio, so here I created an error, using the raise error command, and I put it with log, so it will write to the error log, the SQL error log. So if I go to the SQL error log, we'll see it somewhere over here. And I go to current, and here it is, the error test that I just printed there. And anything that is printed on the SQL error log will also go to the application event log. So if I go to the event log, here, Windows log, application. So here I should see also the same error. So here it is, error 50,000, 7016 error test, the same error. So now the agent will collect this error from this application log, and we can see it on the log analytics workspace. In similar manner, we collect the performance counters. So we go to the workspace that is here, and we want to check that it's collecting data. So we just go to the menu and click on logs. And here I already have the queries saved. So I click Query Explorer, and I have that's query saved for this demo. And I want, for example, the VM, which is this one. So let's minimize the menu here. So the log analytics workspace is like a database, for people that is familiar with SQL. And we have tables. So for the VM, the data is collected on the event table. Everything that is from the event log is stored on the event table. And the metrics collected from the performance counters are in the perf table. And you want to explore each one of the tables. So the event table, similar to a T-SQL query, I can do event pipe limit 100, which is the equivalent to select top 100 in T-SQL. So I don't get all the events, only the first 100. So if I run this Kusto query, I can see all the events from the event log. So the application event log. And then the last 24 hours is the default. So let's see the last hour. So we can see from the last hour, we can see that here is our SQL Server error that we just generated with a raise error command. So it's 500, and the message is this one, right? Error test. So the same error that was on the application log on the VM, so now shows up here on the log analytics workspace on the event table. So in similar manner, so the perf table has the performance counters. You want to explore, the first 100 rows, and we can see all the performance counters that we set up, that we configure. In this case, this bytes second, average second, all the logical this. There was SQL Server statistics here, and so on. So now, if I want to filter just by processor time, similar to T-SQL, I use the where clause here. And if I run it, so now I'm just getting the processor time ones, right? So I can see, several columns here where the values are. So since there are several columns, now I want to just select two columns, which is the the time generated and the counter values. So for that, I can use the project command here. And if I run it, so now I have two columns, the time generated and the counter value. So the next example here is to do an aggregate, similar to a group by in T-SQL. So we have the summarize operator here. So I'm getting the max counter value. But then I'm using a bin function here. So a bin function is to create buckets of time interval. In this case, my buckets are 2 minutes. So every 2 minutes, it will get the max counter value. So if I run this query, so now you can see that every 2 minutes, 442, 444, you will see the max value, and so on. But also in this interface, we can also create a chart. So if I do chart here, so we can see a little bit of the trend, right? So it started with about 37% CPU usage, and then it goes down, and it goes up a little bit. So easy to visualize the data on this interface. Now we will see the next demo, which is on this slide. So we already talked about VM, how to collect the data using the log analytics agent, and we can configure which metrics and logs to collect. And that VM can be on premise or in Azure. So the next demo is the database. So how to collect metrics and logs from a SQL database. So we go back to our portal, which is over here. I go to home. And again, so I already created the database. Doesn't show up here. So let me refresh. Should be somewhere over here. Let me check. Okay, so here is our SQL database that you already created. So I click on it, and you will see that there's already some activity. So on a SQL database, you don't use it at all, so it won't show any metrics. So I created some activity so we can show some data, and that's on. So I use a PowerShell script, but you can do it with Management Studio also. But my PowerShell script, all that is doing is logging in. So I provide the service instance name, the database name, the username, and the password. So this is a demo, but in production, don't hard code the password. And the easy way to insert rows is to use a table that already exists, which is these messages. And I'm just selecting the top 1,000 rows and put it on a stage table so I can control how many rows I'm inserting at a time. And then I put it on the loop, to run these commands. And also an easy way to generate a lot of rows is doing a cross join. So I'm doing a cross join of the two tables of 1,000 rows each. And then I'm just selecting the top 500,000. And then I put it on another stage table. And then I use the inbox SQL command. And then once I'm finished, I just throw the table because I don't need it. And then I do start sleep 60 seconds. That means that almost every minute is doing this insert of 500,000 rows. So I can create some IO activity. So we can see some metrics. So if I see the metrics here, current is running, and these are the metrics for the log IO writes. So here, how to collect the data from a SQL database and from other resources on Azure. You just go to the menu here that is called diagnostic settings. So it's this one over here. And if I click on diagnostic settings, it will show me what we can collect. So all these logs are available. So since I already created, I'll do the edit setting so we can see how it looks like. So all these logs are available for collection. SQL Insight, automatic tuning, errors, but also metrics. So these metrics can be collected also. And then you tell them where to send it to. So my log analytics workspace, again, is PS log. And then once that is set up, you will start collecting the data. And we can see it on the log analytics workspace. So let's go back to PS log. So here I can see on the logs menu, and I already have some queries saved. Let's go to the folder. So this one is DemoDB. Minimize the menu, and similar to the VM. So the database will collect data on two tables. So one is Azure Diagnostics. So this one will collect all the logs that we configure. And the other table is called Azure Metrics. So those are the metrics equivalent to the performance counters on a VM. So if you want to explore the data, we can run the first query, which is Azure Diagnostics, where the logs are. So limit 100, again, is like in T-SQL select top 100. So we can see all the information from the logs here. This one is weights. And then for metrics, we have the Azure metrics table. And here we can see also all the metrics collected. We scroll to the right. Metric name, storage percent, 10 dB, etc. You want to know, which ones are being collected, we can do the summarize count, which is equivalent to a group by into SQL. So I run it, and now we can see all the metrics that are being collected. And the one that we're going to use is the log write percent. So I can filter those using the where class here. So if I run this, I'll get just the log write percent metrics. So, and then we can see the values. And there are multiple columns. So if I want to select only two columns, I use the project again. And if I run it, so now I get just two columns and the percentage here, which is called maximum. And similar to our example with a VM on the perf table, the Azure metrics table we are using here is the summarize command to do an aggregation on buckets of 2 minutes. So if I run it, so we show several here every 2 minutes, but currently 0. So let's, the time range is 24 by default. So let's do the last hour. That is when I started my IO activity script. If I run it, now I can see some data here. And I also can do a chart, so we can visualize it. There are a lot of peaks and valleys, but not too bad. So that's one way to visualize the data in this interface. But when we go to our next demo, we will see another way, which is with dashboards. So let's go back to our PowerPoint slide to see our next demo is how to find the anomalies and patterns using the Kusto function, the machine learning functions that are already built in. So we go back again to the portal here. So I also have the queries already saved. So let's look at errors, for example, which are this query. So remember, on the VM, the errors are on the event table because they come from the application log. So just to do a recap here to look at it. So this is the application event log. And remember, this is our SQL Server error that is there. Remember that it was error test. All right, so now Kusto has an operator called reduce by, which it will find the patterns on the text. On that documentation is over here, and you can use a threshold. The bigger the sample, the smaller the threshold is what it says over here. But it will find patterns, so you don't have to look, all the rows, all the errors. So we can show it here. So here I will say, let's see, the errors on the last 7 days. So it's a bigger sample. If I run it, so you will see that, let's minimize here. So you will see that each, minimize those ones. So each asterisk means that it found a pattern. So it can be replaced by an asterisk. And then there is the string here. So there are 2 that has an error. So one, I put error test, another one test error. So the pattern was a little bit different. Then there is another pattern here, which these asterisks are 11. And the representative text is successfully scaled software protection service. And then I have, for example, login failures. There are 87 login failures, and they're exactly the same text. So there is no pattern, but it's already aggregated there for you. And then SQL Server shutdown, and so on. So instead of looking at each row, you can just quickly run the reduce by operator, and it will find the patterns on the text. So you can easily focus the analysis on a particular text, right? If I'm interested on, okay, why I'm getting this login fail for user SA, you can drill down and query more information on the event log and so on. So another useful function is the evaluate auto cluster, which is similar to the reduce by. It will find patterns, but also it will do like a dimensional analysis. So the documentation is also here in the Microsoft Docs. So you just pass, you can pass arguments or just use the defaults. I'm just using the defaults, and it will return the patterns. So let's look at here. So let's run the auto cluster. And then in this case, I'm auto clustering on 3 particular columns. So that's the reason I did a project. Instead of doing all the columns, I'm doing 3 columns. And I want to see, for example, what are the patterns with the source and the severity level and the description. And I can see that, for example, 77% are from the SQL Server, and then 10% are from the Windows security, and then from the Windows CI PI2, that information. And then if there is a common pattern, it will tell you here for the render description, but they didn't find any, so it's blank. But in this way, also, instead of looking at the hundreds of errors, you can run this function, so it will find the patterns for you, so you can focus your analysis later and query the event where source is SQL Server, for example, or where source is the Windows security. But anyway, so those are the 2 helpful functions in the Kusto language to do analysis of text on the logs. So this one was on the VM, so we can do similar thing with the database logs. So I also have the query. So it will be error.db over here, and let's minimize this and this so we can see it better. So remember that the logs on the DB are stored on the Azure Diagnostics table. So we can explore it. So if we select the first 100, so you can see how they are there. So instead of going to every row, you can run those machine learning functions. So for example, here I will summarize group similar to the group by to see how many there are. So we have on the category, we have query store statistics, runtime statistics, and the last 24 hours, but let's do last 7 days so we can find more variety of categories. Now we have more categories. Errors, we have 3,000 errors. So instead of looking at 3,000 errors, I can filter by this category, category equal errors, and use the reduce by operator with the threshold 0.001, and we'll find the patterns that are there. So in this case, so I already know that 3,000 errors are related to invalid object name. So on purpose, I was querying tables on a different database or tables. So if you do, if I see the representative value of this, the asterisk here, sees messages. So as you can see, there is a syntax error. So messages have 2 S letters, but this one has 1. So that's the reason it didn't find the object. And another error here that find, with the asterisks to find the pattern, but object is the one that doesn't change. So there is already an object name, this table in the database. So other errors. Other errors didn't find a representative text, so it didn't show anything. But instead of going to the 3,000 errors one by one, I can do this operator reduce by, and it will give you a summary of the patterns that are on the text. Similar to our example with the VM, we can also use the evaluate auto cluster. So I chose 3 columns: the error number, the severity, and the message, just to see how it look like. And if I run it, so 99%, the error is 208. Both are the same severity, but there wasn't a representative message that will be exactly the same. But you can see how the data is distributed depending on which of the columns you are finding here, patterns. So 208 is the most common pattern, and severity 16. But yeah, so those are a couple of functions that are very useful to analyze text. So now for metrics, we can use what we call the anomaly function. So let's go to our query explorer. So I already have the query for the anomaly here. So let's start with anomaly database. So here is the table, the Azure metrics, where the metrics are. And then I'm filtering, I just want the log right %. And I'm just selecting 2 columns. So the reason I use project. So if I run just these 3 lines to see how they look like. So you will see that you have several rows with 2 columns, the time generated and the maximum value. But the series decomposed anomalies function, which is also documented on the Microsoft Docs here, series decomposed anomalies. So I'm using the default values, but you can change the parameters here. And I'm using the line fit trend. But if you use the default values, it will still work. And that's what I'm using here. So this function accept a different data type for input. And the data type is called a dynamic data type, which is an array of values. So how do I change these rows with these maximum values here into an array of values? So that's the reason I'm using the make series operator here with a bucket of 2 minutes. So that's the reason my summarize commands has the bucket there. So let me select just these lines so you can see it. And oh yeah, so let me select just the last hour. So instead of rows of values, now I'm getting array of values, right? So here I have all the time generated array of values, and then I have the maximum values here. So now I can provide that input to the series decomposed anomalies. And then what I'm interested is the score, because the bigger the score, that means the bigger the anomaly. So if the score is very low, so the anomaly is probably not that important. So if I run all this for the last hour, so we will see, right, the array of values for the time generated and then also for the score. And also I can use a chart to look at it. And if we compare to our previous chart, so let's run it again. So run it and do a chart again. So you can see here that it started from 0 to 48, and then it goes up and down, peak and valleys, and then it goes down to just 26. So that's the reason the anomaly score is proportional to that difference. So right now, so that's the reason the negative value is because it went from nothing to 0. Oh no, from nothing to what it was, from nothing to this value over here. It was 48. And then there are small anomalies here, less than 1. So it's 0.347 and 172. So it's very small. And then it goes down again. So there's a -2 because on the data that I'm sampling here, so it was, this is a normal. So you can see it goes up and down, up and down, up and down, and all the time it goes more down. So that's the reason the anomaly increased, the score increased on the last value here. So that's one way to do it with the database. So we can do similar thing with the VM metrics. So I have my query here. So remember, I was using this query. Oh, not the alert. We want to use the demo VM. So if I click on demo VM. So remember, our last query was summarizing the metrics. And I do a chart. Oh, let's do just the last hour. Let's see. Oops. Last hour. And do a chart again. And you can see, it was pretty high here. But we will see how the anomaly score turns out. So here, oh, I don't need a new query. I already have it saved here. So it will be anomaly VM, the query. And similar to the query with the database, with the Azure diagnostics table, we can do the same with the perf table. So we can see that here you have this. Let me see. Yeah, not sure it was recording, but anyway, so, okay, so here it is, and I'll run it. But, oh yeah, I forgot to change the query to the last hour. And again, it will show the array of values here. And I can do a chart. And then you can see that the anomaly, it's pretty, the score is pretty high. So it says 4 because if you compare with this one, it is, high over here. So let's go back to our PowerPoint slide to see what's our next demo. So we already analyzed the anomalies and the patterns. So our next demo is a dashboard. So let's go back to the portal. So here, you can see it's a little difficult to, go to this tab to see the anomaly score and, click again or click on this one. So there's a way to put all these charts together with a dashboard. So that's what we're going to do right now. So you click on this chart, and we'll do here in the menu, pin to dashboard. So we're going to pin it to a dashboard. I already have a dashboard called demo. So I'll click pin. And it said, pin to the dashboard. So the next chart is this one for the anomalies. So in similar way, I will click here and do pin to dashboard on the dashboard demo, do pin. So it pinned successfully. Similar way here for the VM. I do pin to dashboard. It's already pinned. And then for the anomaly, we'll also do pin to dashboard. All right, so I already pinned these 4 charts to the dashboard. So where is the dashboard? So we go back to home, and here there is the icon that says dashboard. So now I have the charts over here, but now there are vertical. So let's put side by side so we can see it. So we just click on edit, and you can add other elements, but we just want the charts that we already have. So let's minimize this one, or make it smaller so we can see it better. Maybe a little bit more. And then we can see the anomaly charts side by side. So let's see this way. And then that's for the database. So the VM is somewhere over here. So let's take it here and make it a little bit smaller. Oops. A little more. All right. And then the anomaly one is over here. So let's scroll it over here. This way. Okay. So now we can see it in one screen. So then I do save, and there it is. So now you can see side by side all the charts. And you can change the title. So right now, all of them say analytics. So I can change the title to, so the first one was right log percent. And then this one, we can name it right log anomaly score. Did it. And this one is the CPU percent. And this one is the CPU anomaly score. All right, so now we can see side by side the charts. So here, remember, the score is important. So you can see that it automatically will detect if there is an anomaly, and you can see there is a pattern. Visually, you can see the peaks and valleys. And because it started from 0, or from here to 34, that's the reason that it says -2, and then it goes to the pattern, peak and valley, and then it goes down to what is it, 26. So that's the reason you have a score of 2, I think it is. And then these anomalies are very small, so they're not that important, I guess. So that's the reason the score is very low. And then for the CPU, on the other hand, you can see that this one is a big jump, right? So this one is 37%, and usually is really low, 12% or 3. So that's the reason that the anomaly score is much higher, which is 5. So that's the reason we have the score side by side to the trend or the pattern on the metrics. So you can determine the bigger the score, the more important the anomaly that you can drill down and see why is happening. So you can focus your investigation. But this is how to do it visually, right? So visually, I can look at the trend and look at the score, and then you can determine what's your next step for investigation. But I don't want to watch the dashboard 24/7. So for that reason, we use alerts. And that's the next demo. So if I go back to our PowerPoint slide, we already did the dashboard, how to visualize, side by side, the pattern on the metrics and the anomalies or the anomaly score. So you can focus, where to start the investigation. So now we're going to look at the alerts. So I don't have to look at the dashboard 24/7. So that's our next demo. So the alerts, if I go back to the portal, if I go back to our log analytics workspace, the alerts, there's a menu here that says alerts. It's over here. So that I don't have alerts, but I already have some pre-created here. Yeah, it's over here. The reason it says I don't have alerts is because I probably put the threshold higher, but let's look at it. So here you will see that for an alert, you have to define a condition and then the actions. So the actions could be, what you want to do, email or, what notification, and then you have, like a severity, the default is informational. But on the condition is where the Kusto query comes. So right now, so there's a Kusto query that comes from here. And we're going to explain, why I wrote it this way. So let's go back to this log. Let's go back to the log. That's a little bit higher over here. Okay. So I don't need this because I already have my query saved on Query Explorer. So here are my saved queries. For example, for the database or the Azure metric one. So let's minimize this part. So here, remember the query that we used for the anomaly. We use the series decompose anomalies. So the input is, I need to change from a row of values to an array of values using the make series. But now if I want to query, I need to do the opposite, convert the array of values to row of values. So I use the env expand operator. So remember, so we did this query was to get the anomaly. Oh, I forgot to put the last hour. To get the anomaly, so remember the result was an array of values. So now I need to transform it back to rows of values. So let's run the env expand command. And now let's go back to the way it was, rows and values. And then, so the data type, because it was arrays of values, now I need to define if it was a datetime data type or a decimal data type. So that's the reason I do the project and put the data type, and then I can query and say, okay, which one has the anomaly score, let's say greater than 0.1. So let's run everything for the last hour. Oh, nothing for the last hour. So let's do last 4 hours. So you can see, there are a few here that have this score, so it will show up. And since we are here, in similar way is the metrics for the VM using the perf table. So remember, you have this query, but now for the alert, we need to do the alert VM query, which is over here. So similar to the one. So we want to see If we have, let's see, on the last 4 hours, anything with anomaly score greater than 5, and yeah, there is one. This is one. It says 6. So that way you can write the alerts. So let's go back to the alerts. Use log. Alerts. Then manage rules. So this is the alert DB. And this is the condition. And this is the query that we look at the other one. And I probably, I put greater than 1. So I only want to be alerted when the anomaly score is greater than 1. But let's see if we put 0.1. There's anything, yeah, there was 1 here. So if I would put 0.1, we would get an alert on the last 30 minutes. And then this query will run. So, based on the number of results. So if it's greater than 0, so if this Kusto query returns something, you will alert. And the query runs every 5 minutes on a 5-minute span. So that's the default. So I just changed it so we can see some data. But that's the way you will set it up. So I do save. And then we can look at the other one that for the VM is similar. So let's look at the condition. So what did I put here? So I put greater than 5, but didn't find anything on the last 30 minutes. But again, so you can change the score, right? Because the score of 1 is not important to you. You do a score of 5, right? For example. But on the last 30 minutes, so I think the anomaly happened more than an hour. So I can change the frequency here. For example, if I do 30 minutes, and I have to change this one also to 30. So now it will say, okay, in the last 3 hours, I did have an anomaly greater than 5, right? Because again, I don't want to watch the dashboard 24/7. So you determine which one is the score that you want to be alerted. The bigger the score, the bigger the anomaly. So if I do 5, for example, then we will get an alert for 5. But that's the way the alerts work. So let's go back to PowerPoint slide. And so that's our last demo. And just to summarize what we have learned today. So we learned how to collect the data, how to collect the metrics and the logs for VMs and databases, and how to find the anomalies and patterns using the Kusto language that already has machine learning functions that you can call, and you don't need to be a data scientist to find those anomalies and patterns. And also you learn how to visualize the results on a dashboard, and you can compare side by side the patterns and the anomaly score, and visually you can determine if the bigger the score is bigger the anomaly. But if you don't want to watch the dashboard 24/7, you create alerts, and on the alert you can also use the Kusto queries that find the anomaly score, and you can determine which score do you want to be alerted. If you want a big anomaly, is the score is much bigger. And that's it. So hopefully you like this demo. And also there is a link to the Microsoft Docs here. So these are the links to several of the concepts that we touch in this presentation. So you can, deep dive more or doing these demos by your own, or learning more. You can go to these links, and also what are the Kusto operators that we use. So then that's it. And so we can give a special thanks to Microsoft for supporting Data Platform Geeks and SQL Server Geeks community initiatives. And thank you. And there are 3 ways to win prizes. There are here in this slide. And remember that I will stick around for questions. So feel free to post your questions in the chat. Thanks. Bye.